6.1, exponential functions. First of all, an exponential function is a non-linear function. So a linear function has a constant rate of change. It makes a line when you graph it. An exponential function is nonlinear, so this is not going to make a line when we graph it. It can be written as y equals a times b to the x power, and the key here is that the x is actually an exponent or a power. Okay, so that's not b times x, it's b to the x power. And then the last thing is that it has a common ratio, which means what we're going to be doing for an exponential function is we're going to be multiplying by something. So if you remember our linear functions were constant, so we would add 5, add 5, add 5, or subtract 6, subtract 6. In this case, an exponential function is going to be multiply by something, multiply by something. So multiply by 2, multiply by 2, multiply by 2. That's the big difference between exponential and linear. So identifying and evaluating functions, number 1. Does each table represent an exponential function? Yes or no? And then we have to explain. So first of all, I'm going to look at my x values, and they are going up by 1. So 0, 1, 2, 3. Then I'm going to go look at my y values. And if this were linear, I'd be looking for either an increase or a decrease by a constant number. So probably either like adding or subtracting. But in this case, if I'm looking for exponential, I'm looking for multiplying by something. So if I'm really looking at 8 to 4, the question would be, well, how do I get from 8 to 4? And option 1 is I subtract 4. But that would be if it was linear subtraction. If it's exponential, I have to multiply. So the other option is, well, 8 to 4, you cut it in half. So this could be multiply by 1/2. Well, let's see if that holds true from 4 to 2. So in order to get from 4 to 2, I could cut it in half. So that would be multiply by half. And then we have to check that again, 2 to 1. Okay, cut it in half. So multiply by 1/2. So is this an exponential function? Yes, because it has a common ratio of 1/2, meaning your y values are always decreasing by 1/2. Letter B. Okay, in this case, my x values, -4 to 0 is going up by 4, 0 to 4 is going up by 4, 4 to 8 is going up by 4. So at least my x values have that constant rate of change in them. Now my y values, once again, I'm going to try to figure out what's going on here. So from 1 to 0, well, I could say I subtract 1. Oh, okay, but if this is exponential, I really want to know, well, how would I multiply that? And the only way you can multiply a 1 to get to 0 is to multiply by 0. Well, if I want to get from 0 back to -1, I don't think multiplying by 0 is going to work, because that's just going to get me a whole bunch of zeros. So 1 to get to 0, you would have to subtract 1. 0 to get to -1, you would have to subtract 1. -1 to get to -2, you would have to subtract 1. Well, if I'm subtracting 1 and I'm looking for an exponential function, this would be no. Okay, this is not an exponential function, and it's because it has a constant rate of change. And if it has a constant rate of change, then that makes it linear. So this isn't an exponential function. This is a linear function.